Hey, I wanted to make you a video of the test review. Use this, watch it, rewatch it, share it with a friend. I don't care, but I hope this helps. Okay. Let's get started. So, looking at this first problem right here, guys, it says find the amplitude, period, and phase shift, the vertical shift of each of the following trig functions. All right. If none, write none. All right. So, on this first example here, sorry about that. All right. On this first example here, it says y equals 3 sine of 7 theta plus pi minus 6. The amplitude right here is out front, guys. The amplitude is always right here. All right. And I want to write it out. This is A, K, C, and H. So amplitude 3. The period. Remember we use 2 pi all over K. All right, well K is 7. All right, so that doesn't simplify. So the period is 2 pi over 7. The phase shift. Take the entire parenthesis. All right, the entire parenthesis. Set it equal to 0. All right, and solve for it. All right. So you would go. I'm gonna do it up here. 7 theta plus pi equals 0. The entire parenthesis. Set equal to 0 and solve it. So subtract pi. So you have 7 theta equals negative pi because I subtract pi over here. Minus pi. All right, and then divide by 7. So theta, see that cancels out. Theta equals negative pi over 7. All right. So negative pi over 7. The other way to do it, all right, the other way to do it is to use the equation negative c over k. So you pick, all right, negative c over k, meaning if I take c, which is pi, all right, put it over k, which is 7, and then don't forget the equation is negative. So negative pi over 7, which is what we got. So you pick, I don't care which one, but there you go. Now the vertical shift, all right, we have a minus 6 down here, so we have minus 6 or down 6. All right, is there a reflection? No, there's not. Notice there's no negative here or negative here, so there's no reflection. Over here, all right, negative 5 tan of 10 theta plus 5 pi over 4. All right, amplitude. All right, remember, you want the absolute value of A, so 5. The period in this case is going to be pi over k. All right, with tangent it's a little different. All right, instead of 2 pi over k, you go pi over k. All right, pi over k. Golly, my k is terrible. Let me try it one more time. Pi over k. All right, so in this case we have pi over 10. So the period is pi tenths. The phase shift. All right, again, same way. So again, negative c over k. All right, you can do it that way, or you can take the whole parenthesis, set it equal to 0, and that'll give you your phase shift. All right, I'm just going to do negative c over k real quick. I think that's a little quicker right now. So 5 pi over 4 divided by 10. All right, so we change this to multiplication, and flip the bottom. So we have 5 pi over 4, don't forget your negative, right, that negative times 1 over 10 gives me negative 5 pi over 40, which reduces 5 divided by 5 is 1, so negative pi, and 40 divided by 5 is 8, so negative pi over 8. All right, and then the vertical shift. All right, there's no vertical shift. There's nothing out here, guys, so we put none. And is there a transformation? Yes, we have this negative right here. All right, or excuse me, is there a reflection? Yes, that negative reflects x axis. All right, reflects x axis. All right, right here. Let's see. All right, amplitude, absolute value 2. Man, pins all over the place. All right, period. All right, 2 pi over k. Well, guys, what's k right here? All right, I can't stress this enough, man. Sometimes this confuses everybody. Guys, it is theta divided by 4. Well, guys, what is K? All right, K is 1/4. So if I do 2 pi over 1/4, keep, change, flip, that's 2 pi times 4 over 1, that's 8 pi. All right, now the phase shift. The phase shift, negative C over K, or take the entire parentheses, set it equal to 0. All right, so if you want 5 pi over 6 divided by 1/4, all right, keep, change, flip, you end up with negative 5 pi over 6 times 4 over 1, which gives us a negative 20 pi over 6. Everything is divisible by 2, so you get a negative 10 pi over 3. That is our phase shift, negative 10 pi over 3. All right, and just for the sake of showing it, guys, if you were to take the whole entire parenthesis, set it equal to 0. Well, you know what? I'm not going to do it. I'm just going to keep going. Vertical shift, we got up 8, so plus 8. 8 up. And then is there a reflection? Yes, there's a reflect over the x-axis. Now, right here, the directions are there. Hopefully you have your paper in front of you. It says, given the following amplitude, period, phase shift, vertical shift, write the correct function. All right, so it's sine. So we know we have sine. We have an amplitude of 7. All right, we have a period of 4 pi. So let's undo that. Remember, you have 2 pi over k. Well, we don't know what k is. We have to find actual k. Remember, k goes here. It's k theta, right? Or kx. All right. So we know what the period is, or we know the period equals 4 pi. So now just solve this for k. Well, how do you do that? Multiply by k on both sides and divide by 4 pi. So if you multiply by k on both sides, you get times k times k. All right, so you have 2 pi equals 4 pi k. And I want k by itself, so I divide by 4 pi on both sides. All right, and you'll see that reduces to 1/2. All right, the pi's cancel, by the way. So that's 1/2. So k is 1/2. So we have 1/2 theta. All right, or 1/2 x. Here, I'm just going to write 1/2 x. All right, 1/2 x. There's the work. I'm going to erase it. Just rewind if you need to see how I did that again. All right, and next we got to find the phase shift. The phase shift is pi over 4. Well, all right, again, remember negative c over k, right? And it equals, they told us, pi over 4. And the fact you can run into right here is you got to respect this. All right, they told us that it moved left. All right, so negative. It moved left pi over 4. All right, so now we're going to solve by solving for c. So I'm going to multiply by negative 1/2 on both sides. I know you're like, why negative 1/2? Because this is negative, so I want to clear the negative. But also I want to get rid of this denominator. So I'm going to multiply by negative 1/2 on both sides. All right, the negative cancels, so c is by itself. And over here you get negative times negative is positive. All right, pi times 1 is pi. And then, sorry, my alarm went off. And then 4 times 2 is 8. So c is going to be, all right, pi over 8. You also know, guys, remember in the parentheses you do opposite. So if it went left, that means it's plus, okay? Man, again, if you got questions, just rewind it, okay? Come back to it. Now, last thing right here, man, is up 9. All right, up 9, so plus 9. And there's our equation right there. All right. Now, right here we have a cosine function. All right, with an amplitude of 10. All right. Now, we need to find the period. The period is pi half. So, guys, I have to find k. I got to find k. So, remember, all right, we have 2 pi over k equals our period, right? Well, in this case, we know what our period is. Our period is going to be pi over 2. Okay. So, again, multiply by k on both sides. So, you have 2 pi equals pi pi half k, but I want k by itself, so I'm going to divide by pi halves on both sides. And since I have a whole number over a fraction, I'm going to do keep, change, flip. So 2 pi times, I changed it and flipped it, right? See that? So the pi's cancel, and I'm left with 4. So 4x. All right, like that. Or 4 theta, whatever you prefer. Okay. Now we got to find the phase shift. Well, they told us the phase shift was we got to find C, excuse me. Phase shift 10 pi to the right, which means this is going to be negative. It's to the right, so that's going to be negative, okay? Now we got to phase shift 10 pi. All right, so remember the equation negative C over K? All right, well, we know what C is. We know what K is. All right, we have negative C divided by 4. All right, and that equals 10 pi, right? So now we just got to undo this, all right? And we solve for C. And how do we go about solving for C? We're going to multiply by negative 4 on both sides, all right? Negative 4, excuse me. Negative 4, the 4s are canceled, the negatives are canceled, right? And so I multiply by negative 4 over here, and I get negative 40 pi. All right, so remember I told you it's going to be negative, so negative 40 pi. All right, that's our phase shift, all right? And then vertical shift down 8, so minus 8. There's our function right there. All right. All right, now we get to the fun part, guys. Graphing. So what I want to do is, I want to start by answering these questions. All right, what is the amplitude? All right, the amplitude is going to be 2. Right, see the 2 out front. What is the phase shift? All right, the phase shift, I take this whole thing, minus pi, set it equals 0 and solve it, so add pi over, and then divide by 2. So x equals pi halves, right? X is pi halves, so pi halves. All right. The period, 2 pi over k. K is 2, so 2 pi over 2 gives me pi. And the vertical shift is up 1. All right, I answered the critical stuff. All right. Now I got to grab this. So, sorry guys, I'm eating Cheerios, man. Dry, with no milk. Anyway, here's what I'm going to do. Let's do this. Oh, wrong thing. So that equation is negative 2 cosine of 2 theta minus pi minus 1. All right. And again, those critical points, those 5 critical points for cosine are 0, 1, power 2, pi, 3 pi over 2, and 2 pi. So high, middle, low, middle, high. All right. So first we're going to do, and my students will get this, all right, the inverse of k. Well, k is 2. So I'm going to multiply all the x values by 1/2. 1/2 x is what I'm about to do. All right, so I should have, let's do this. It's in the wrong place. Sorry about that. All right, 1/2 x. Because k, we use the inverse of k, that's k. So 1/2 times 0 is still 0. 1/2 times pi half is pi over 4. All right, just do pi over 2 times 1/2, right? 1 times pi is pi, 2 times 2 is 4. All right, it's 4. Anyway, pi times 1/2 is pi halves, and 3 pi over 4, and pi. All right, right there. Now, we have a phase shift, which we got to apply next. So we're going to do x. What do we say the phase shift was? Was it positive? All right, pi over 2. So we're going to do plus pi over 2. So guys, you got to get common denominators. But this one's easy. 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, which is pi. All right, here, there you go. Pi over 2 plus pi over 2 equals 2 pi over 2, which is pi. All right. Pi plus pi over 2 is going to be 3 pi over 2. All right, again, get common denominators. I need to put that over 2, so put that over 2. All right, plus pi over 2. Gives me 3 pi over 2. Right? Oops. 3 pi over 2, negative 1. Sorry about that. 3 pi over 2 plus pi over 2 is going to be 4 pi over 2, or 2 pi. And 2 pi is going to be 5 pi over 2. All right. 1. Yo, get common denominators. All right. Right. I need a denominator of 2, so I got to put 2 at the top. Right. 2 times 2 is 4. That's not 22. So 4 plus 1 is 5. All right. If you didn't understand that, rewind it and listen. All right. And you'll hear it again. Okay. Now, when you do the y values now, you got to multiply the y values by the whole entire value out front. So negative 2. So negative 2y now. So these x values won't change. All right. Now, negative 2 times 1 is negative 2. And what that does is account for the reflection of the x-axis. 0 times negative 2 is still 0. Negative 1 times negative 2 is 2. 0 times negative 2 is 0. And 1 times negative 2 is negative 2. All right, it turns it upside down. And finally, we have down 1. So y minus 1. So again, these x values won't change. I'm not going to write them again. All right, well, actually, y'all need to see that. Sorry about that. So I will write them again. Now, hey, you know what? This is wrong. That should be a plus 1. So y plus 1. So negative 2 plus 1 is going to be negative 1. 0 plus 1 is 1. 2 plus 1 is 3. 0 plus 1 is going to be 1. And negative 2 plus 1 is negative 1. All right. So those are our values right there. So the cool thing about these is when I go to my y graph, or when I go back to my graph, sorry, wrong way. Whoop, wrong way. When I go to my graph, boom, there it is. All right, that is my x scale, the values I just had. So, you know what I mean? If you need to go back and look at them, man, wrong way. Write those down, okay? Write them down. Take a picture, however you need to get that transferred back for your brain. All right, and then let's go back and sketch our graph. All right, again, those are the x values we use. And those are the y values. So when we plot it, we have pi over 2 negative 1. We have pi 1. We have 3 pi over 2, 3. I'll put pi 0. Man, sorry about that. Pi 1. 2 pi, 1, and 5 pi over 2 negative 1. So there's our graph. All right, and then the cycle will just continue, like from here to go, boom, boom. But you only have to focus on this. All right, that's not the point. Right. The point is you can grab this graph to scale. All right, it'll just continue like that. All right, good stuff. So yeah, actually, no, leave that. I don't know why I erased that. Let's move the scale right here. I need space for this problem right here. All right, sine. Okay. We don't have an amplitude, so, or we do. There's a 1 right there, so we're going to write 1. All right. Phase shift, take this whole parenthesis, set equals 0, plus pi, divided by 4, pi over 4, or negative c. Over k, right? Now, notice c is negative, so that becomes positive. That cancels over 4, pi over 4. So however you want to do it, all right? If you miss that, man, just rewind and listen. the period, 2 pi over k, or 2 pi over 4 becomes pi half. All right, and then the vertical shift is -2 or down 2. All right, so now I need to graph this thing, okay? And let's clear this off. All right, and let's get to charting. All right, sine of x is the following. So we're going to do the inverse of k. All right, so if you remember, let me write it up there real quick. It was sine of 4 theta minus pi minus 2. That's minus pi. Anyway, the inverse is 1/4, so 1/4 x. All right, so if I do 1/4 x, I end up with 1/4 times 0, 0. 1/4 times pi half is going to be pi over 8. Times 1/4 would be pi over 4. Times 1/4 would be 3 pi over 8, and then times 1/4 would be 2 over 4, which is pi halves. All right. Now we got to do x. What do we say the phase shift was? Go back and look at it. There we go. Phase shift was 1/4, or pi over 4. All right. So I'm going to add pi over 4. So doing so, we get 0 plus pi over 4 is pi over 4, right? Remember, our phase shift tells us where we start. Pi over 8 plus pi over 4 when you come denominators, so I got to make pi over 4 8. So here we go. I'm just going to convert this so we can do it. Pi over 4, I want to have a denominator 8, so I multiply by 2 at the bottom and multiply by 2 at the top. So that's 2 pi over 8. So now, pi over 8 plus 2 pi over 8. This is pi over 4, guys. Okay? I understand I converted it already. So 1/8 plus 2 pi over 4 is going to be 3 pi over 8. All right. Pi over 4 right here plus pi over 4, because look, that's the converted form. Okay. I can just do pi over 4 plus pi over 4. It's 2 pi over 4. All right. 2 pi over 4 becomes 1/2. All right. 2 pi over 4. There you go. So you can see it. That's 1/2. 3 pi over 8 plus 2 pi over 8 is 5 pi over 8. All right, because remember I converted that. And then pi half. Ooh, I need a half. So I need to get that to 4. So pi over 2 plus. Put it back. Put it back. Don't touch. Don't touch. Thank you. Pi over 2 plus pi over 4. We need to count the denominator, so multiply this by 2, so multiply that by 2. So that's 4 now. So 2 pi over 4 plus 1 pi is 3 pi over 4. All right, so there we go. Then we need to add in the y value. All we have is down 2, so minus 2, y minus 2. So all these x values will stay the same. All right, 3 pi over 8, negative 1. Pi over 2, negative 2, 5 pi over 8, negative 3, and 3 pi over 4. Whoa, that's 0. Negative 2, there we go. All right, so these are how you're going to plot it. You're going to plot it just like that. These are your x values that we use, all right? So you go to the graph. You're going to write out your x values like we had written down. Pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, 3 pi over 4. Alright, and then 0, 1, negative 1, negative 2, negative 3, 1, So we have pi over 4. So pi over 4 negative 2. 3 pi over 8 negative 1. Pi over 2 0. 5 pi over 2 negative 3. And 3 pi over 4 right there. So there's your graph. Alright. So that's how you graph this problem. Okay. Man, I'm about to fight everybody in this mug, man.
No, that's two. Because it's absolute. The negative mean it's reflected over the.
Alright. Why is it no amplitude? There's no amplitude because there's no maximum. Alright, we're gonna use that though. Okay, we're gonna use that. Alright, the phase shift. Alright, is there a C value? No, there's none of that either. Alright. No phase shift. Or I'm gonna go with 0 pi. There's a reason why. I'm gonna tell you in a second. Alright, the period. Alright. Y'all remember how to find the period of tangent? Pi over k. Pi over k. For tangent and cotangent, pi over k. Alright, so what's k? 1. So we have pi over 1, which is pi. And then the vertical shift is what? Up 1. Alright, now listen, again, let me reiterate. Guys, tangent only has a period of pi. You with me? So we don't use 2 pi over k. You follow me? We use 2 pi over k for sine, cosine, cosecant, and secant. Not with tangent and cotangent. Tangent has a period of pi. Got it? Now, if you... how do I want to explain this? Alright, so this is the parent function for tan. So what do we need to do? We need to stretch it by -2. Alright, and reflect it, and we also need to move it up 1. So look, take this point right here at 1, right? If I reflect it, it goes to what? Where would this go?
2.
It would go right. I'm sorry, what? So this y value right here is, this is pi over 4, 1. Alright, we're going to multiply 1 by -1, which is at -2. And then we got to move it up 1. So there we go. This is 0, 0. If you multiply by -2, it's still 0. And then you move it up 1. And this point is -1. If you multiply -1 by -2, Jade, I use your alias. It'll be 2, right? And then you got to move it up 1. So it's 3. So that is our new tangent. Oh, that's terrible. So that blue line doesn't exist anymore, so let's get rid of it. Right? And then you just continue that process. So you go over it past the next asymptote and do it again. Right? Asymptote. There's an asymptote. Oops, too far. There we go. And there's our asymptote. Oh, I cannot draw a straight line.
That probably take.
All right, there's our next. Yeah, that's right. Right, and do it again. And there's your tangent graph. All right, for this next one, cosecant of theta, negative cosecant theta plus 2. All right, amplitude, what's amplitude? 1, right? We got an invisible 1 right there. Phase shift, is there a C? So phase shift will be none, period. What's K? 2 pi over 1, good. K is 1, so that's 2 pi. What's the vertical shift? Up 2. All right, what's your question? All right, so if you remember, right, cosecant is the inverse of sine, yes? So if I continue this pattern throughout the graph, I'm going to show you how simple it is to make your cosecant function. All I need are these points. All right, and we're going to apply the transformations to those points, okay? I need to, first of all, do what with each point? What do we do with each point? Reflected, right? So that needs to go here. Let's do it in another color. That needs to go here. That goes there. That goes there. That goes there. Y'all follow what I'm doing right now? I'm applying the transformations. All those red points, which was sine, right? I move them up too. So I reflected them all. All right, so I'm gonna get rid of that. They're gone now. We reflected them. And now the blue dots. And now I'm going to move them all up too, right? So move that up too. Move that up too. Move that up too. Move that up too. That up too. Up too. Up too. Up too. So now, where are the cosecant functions? Right here. Right here. We'll just continue the pattern. Only difference is if there was a phase shift, you would just move these points left or right according to the phase shift. But the same process happens. All right. Amplitude. What's amplitude? 2, right? Phase shift. Is there a C? So we have none, right? Or 0 pi, because that's where I'm going to start. Period. We got 2 pi over k. What's k? K is 1/2, right? Keep change flip. That gives us 4 pi, and the vertical shift is down 1. All right, down 1. Now, secant is the inverse of cosine. So high, middle, low, middle, high, right? I'm gonna label this X scale up real quick. So this is cosecant, and again, we don't need those middle points. All right, those middle points are all asymptotes. All right, so what do we do with Y first? Multiply by 2. Well, all right, so let's multiply all the X values by 2 because K is 1/2. I'm glad we talked through that. That gave me an idea. So I should mention that in the video, right? Right? Since K, we have theta over 2. That's 1/2 theta. So K is 1/2, which means we need to multiply all these X values by the inverse of K, which is 2. So 0 times 2 is 0. What is this point? That's pi. So if I multiply by 2, it's 2 pi, right? And then this point right here at 2 pi should be 4 pi, which I'm going to put way out here. Right? And then we got to multiply by 2 and then move it down 1, right? So this is 1. 1 times 2 is 2. And then I move it down 1. Yes? All right, this point right here. Negative 1 times 2 is negative 2. And then we move it down 1. So that point's there now. Right? And then this point right here, we multiply by 2 and then move down 1. So it's back right there. So there's our new points. And then when we sketch our new cotangent, our new secant, sorry. I said cotangent. There's our new secant.
Hey, that probably take her.
Oh, look, that should be 2 pi. So 1 pi. 1 pi. 2 pi. Hey, this is wider than that. It's 2 pi. Because it's half of a period. Huh? Question? There we go. There's my asymptote. Because this thing has to be 4 pi wide. So from here, negative pi to 3 pi, that's 4 pi. So there we go. Oops, I meant to put the asymptote there. Oh, this question. Gotta recycle that. John is sitting on his front porch and he sees a hot air balloon. So here's John. And he sees the hot air balloon in the distance. The angle of elevation from John to the balloon is 32 degrees. All right, if John is 621 meters from the spot on the ground where the balloon took off. So, right, here's the spot right here. So that means this is 621 meters. All right, from where it took off. Was a terrible triangle. Yeah, I'm telling you, man. I failed arts and crafts, apparently. And they just passed me with a smile. There's our angle, right? Oops, what is it, 32? Right. 32 degrees. Then we answer what is the altitude of the hot air balloon? Right. So we're looking for that. So how would we solve that? What's this? What's this? Adjacent. Which identity is that? Yeah, tangent of theta, which is 32, equals opposite over adjacent. So now we just solve for h. So we multiply by 621 on both sides, right? So we punch that in. Young Jade got us. It's okay, so I do. So 388 feet, 0.04. Cool beans? All right, last problem. All right, tangent. Where's tangent undefined? Do y'all remember the rule for tangent? Where's undefined? All right, think about the unit circle. All right. Tangent is y over x. What would you get if you had a unit circle? Right? You got 0 radians, which is, 1 0, right? You got 45 or pi over 4, which is radical 2 over 2, radical 2 over 2. You got pi over 2, which is 90 degrees, right? And that point is 0, 1, right? You got 3 pi over 2, and that is negative radical 2 over 2, radical 2 over 2, right? And then you got pi, which is negative 1, 0. All right, which one of these values will give me an undefined value for tangent? And remember, tangent is sine or y over x, sine over cosine or y over x. So where would I get undefined values? Pi over 2. I see that? That'll be 1 over 0. All right, pi over 2. All right, and where else? Give me another one. What would be another one? What if I went this way? What if I went negative pi over 4, negative pi halves, right? This is negative radical 2 over, positive radical 2 over 2, negative radical 2 over 2, and this would be 0, negative 1. So where else would it be undefined? Negative pi over 2. All right, because that would be negative 1 over 0. Now, in reverse, think about cotangent. Remember, cotangent equals x over y. So where would that be undefined? 0 radians and pi radians. All right, what's the period for sine, cosine, cosecant, and secant? The parent function, 2 pi. All right, what's the formula to find the period, guys? 2 pi over k, good stuff. What's the period for tangent and cotangent parent functions? Pi. What's the formula to find the period? Pi over k. Good job. I'm done making this video.